Okay, so for example, 7, you're asked for each function given, describe the limit as x approaches positive infinity and negative infinity. Of course, this is an infinity from the left and infinity from the right, right? You can't do that with infinity. So they have to say negative infinity or positive infinity. And guys, this is all about end behavior, right? Come on, cubic function. No matter what, it's going to go, it's positive cubic function, so it's going to look like that. So we can say the limit as x goes to infinity of f of x is infinity, and the limit as x goes to negative infinity of f of x equals negative infinity. So part B says g of x is negative x to the fourth plus blah, 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 blah. Because we don't care, right? We don't care about this piece because it's going to be insignificant. The more you go up on this, the more insignificant that will become. Now, this is at the end, at end behavior only. Okay, so this is a fourth degree, meaning up, up, or down, down, right? But it's negative, so it means it has to go like this. So the limits would both be negative. The limit as it approaches infinity of g of x, is equal to negative infinity, and the limit as x approaches negative infinity of g of x equals negative infinity. Okay, C is h of x is a positive cubic, a negative cubic, so we would be going this way now. So it would be the limit as x approaches infinity of h of x is, no, I did that wrong. Blah, 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 blah. No. Okay, erase that. If it's negative, it's going like that. Okay, so as limit as x approaches infinity, f of x is negative infinity, and the limit as x approaches negative infinity, f of x is positive infinity. All right, and let me just erase a little bit to do D. Okay, so D says k of x is equal to pi minus 0.001x. So this is a linear equation with a negative slope, so you can look at it like that. And this is what we do when we look at end behavior, guys. Limit as x approaches infinity of f of x would be negative infinity, and the limit as x approaches negative infinity of f of x would be infinity. Number 8 says, hey, look at this graph of 2x minus 4 over x minus 3. Describe the asymptotes using limits. So for the vertical asymptote, we've already done with one like this. We would say the limit as x approaches 3 of f of x is equal to 3 from the left, negative infinity, and the limit as x approaches 3 from the right, f of x, is equal to positive infinity, and the limit as x approaches 3 of f of x doesn't exist. And so we can say that there's a vertical k of x has a vertical asymptote at x equals 3. Now the horizontal, you're using end behavior as it goes to infinity. So the limit, if the limit as x goes to infinity of f of x is equal to 2, isn't it? And the limit as x goes to negative infinity of f of x equals 2. Therefore, you have a horizontal asymptote at y equals 2. So that's really important to say. That's why you have a horizontal asymptote and that's why you have vertical, using limits, okay? Those are important topics, okay?